Hey everybody, Steven here. So this is going to be a exam review of the Architectural Technology 1 from 2019. So in this review I'll go over section A, question 1, all about the sizings, and then I'll go through question 2, but just the B part, so about the risk matrix. And finally I'll go over question 4 about the bracing. So I'm just going to quickly jump back into Photoshop and then we can start. So like in the previous exam review, you would have like a descriptions of the building, and for the sizing, what's really important is to highlight the wind zone, because this can affect the sizing. So this is the very high wind zone, and yeah, so let's go here. So that's the section, floor plan, and the first question is asking about the load bearing wall. So the size of the studs in the load bearing wall at 400 centers. So first we need to locate it. So it's line M. So you can see M is here. So this is the wall they're talking about. And if you look at the section right there, section X, so there'll be this wall here. So that's the one that we need to find the studs for. So normally you would get this table there, and I'm just going to turn this one off, and then I can here. So we need to find the sizing at 400 centers. So let's just go here, and so first what we know, it's going to be a very high. Is it very high? Yeah, very high wind zone. And then we know that that wall is the same as this wall here, and that's the values 2.4. So it's around there. And they ask us at 400 centers, so it's this. And so we know it's going to be in that column. And here they ask for the loaded dimension. So we need to know how much of the roof structure is carried by that wall here. So you get the dimension here, 3.1. That's the length of the rafters. And we know that the loaded dimension will be divided by 2, because that rafter is supported by the wall on this side, and on that side supported by the reach beam. So they share the load. So 3.1 divided by 2 equal 155. So that's the loaded dimension. And if we go back to our table, so we go very high, loaded dimension, so it's 2, because it's above 1.5. And then we just need to go all the way here under that table. So it's 90 by 45. So that's going to be the stud size. And let's go back here, section question, the board. So this one is going to be 90 by 45. Okay, now we need to size the maximum center of the studs in load bearing wall line C. So line C, and maybe I'm just going to change color. Line C is this one. Is that wall, and you can see that section. So if you would look into elevations, so from this side, so it would have the same shape as this. So that will be the shape of that wall, kind of. And then you would have that opening here in the middle. So it'll be something like this. So now we need to know the size of the load bearing wall. So you can see here it's a bit higher than the 2.4 because that wall is going all the way to the ridge, so we need to include that into our calculation. Um, so here, the wall, so from here to here, that's like 4 meters. But then I think it would include some of the rafters. Did they say anything about the rafter size? Not really. But I guess the wall will be about 4 meter to 4.2 up to that level. So that's what we need to consider. That's the maximum height of that wall. Okay, we're just gonna answers and send that off. So now we need to size it. So the wall height is gonna be, it's about 4.2, and still in very high wind zone. So now we need to find out what's the loaded dimensions. So what are the elements that this wall is carrying? So it's carrying mainly the ridge beam here, but this spot here. So that's the ridge beam, and so that ridge beam is actually carried by that wall there and this wall here. So the loaded dimension of that beam will be half. So it'll be 3.6 divided by 2. 3.6 divided by 2 equal 1.8. So that's our loaded dimension. And if we go back to our table, so that'd be 1.8 is lower than 2, so it's this one. And I guess if we move all the way to the table, those, maybe let me switch color. Those value here, oops, those value here are the one that we can select from. And so we could either choose 400 140 by 90 at 400 centers, or 190 by 45 at 600 centers. I think both answers are correct. I mean, you could choose 300, but it's not really a common spacing. And in this case here we had 400, so I'd say yeah, either both of them, 140 by 90 at 400 or 190 by 45 at 600. So those could be used. Now let's go back to our question and answers board. So here we can, oops, let's say 140 by 90, 400 centers. And now we need to size the lintel over the window 2. So window 2 is this one here. So that's the window, and the length of that window is 2.1. That's important. And turn that off. And where is the lintel? So that's the lintel. Just delete this. So that's the lintel table. So we know the loaded dimension. Okay, so what's the loaded dimension? So it's the weight that this lintel is carrying. So it's usually to carry the rafters that is on the roof. So it's this element here that's carry. So the lintel is there, just above the window, and it's carrying that that rafter. So half of the load is carried by the lintel, the other half is carried by the ridge beam. So similar to what we had before, so the loaded dimension would be 1.55, and I think from the description below, before, it was a metal roofing, so it's a light roof. So this one here, and the span, so it's like the width of the window is 2.1, so it's this one here. And then if you go up, so that's the sizing of the lintel, 140 by 90. And back to the question. Now the size of 90mm thick rafters at 1200 centers over the living area, and fully describe the fixing type. Just going to delete that. So the living area is this spot here. So now look at the section. So there will be this spot here. So they want us to size this rafter there, and they did say 1200 centers and 90mm thick. So let's go to our rafter table. Oops. And I'm just gonna go back to here, delete that. So we need 1200 centers, so that's where we have to work from. The span, so it's from here to here, and actually, well, it's here, 3.1, so it needs to be at least 3.1. And oh wait, I think another wind zone span should be multiply. So we need to multiply our span, which is 3.1 multiplied by 1.1 equal, calculators, so 3.4. So that's the span that we need to work with. And so we have to go down 3.4. We get this one, but then we forget here it's 190 by 70, but they ask us 90. So we go down, it's 4.1 here. So I would pick 190 by 90, and the fixing type would be F. Yep, so that's how I would do it. Make sure, like, if in the questions they specify this, the sizing, make sure you take that into consideration, because here 90 in 1200 centers. Okay, now width of the 90mm thick ridge beam and beam to stud fixing. So the ridge beam is this one, and needs to be 90mm thick. Let's go to the ridge table. Okay, so it's a light roof. We know that we need to find out what's the loaded dimension. So what are the weight that is resting on that ridge beam? So the ridge beam is this one. So it's carrying the roof, so it's carrying the rafters. So half of it is carried by the wall here, and the other half by the ridge beam, and the same on the other side. And because we know it's 3.1 that side, this was is 3.1 as well. So the loaded dimension would be 3.1, because it'd be 1.55 plus, so 1. 1.55 plus 1.55, so you'd get 3.1 as well. So that's our loaded dimension. And so we have to work around here. Light roof and the span. So what's the span of this? So right now the ridge beam going all the way from here to here. So that'd be like 3.6 plus 750, so we'd get 1 meter 1.5. Yeah. No, 4.3. 4.35. So that'd be the maximum length of the ridge. But because you actually have a wall there, so that we act as a support, so the span is actually just this. So it's going to be 3.6. Okay. So we need to look for a span. 3.6. So you get this one, but because it's only 70, we need to keep going. So it's 240 by 90. And the fixing, so it's this one, huh? Because in the description they were asking for a 90 millimeter thick beam, and the fixing is I, so it's gonna be this one, and ridge beam to build up studs. So those are the fixing. Okay, I think that's it for question 1. Now let's go to question 2. So this one is about the risk matrix, and we need to fill those out. And this is normally a table that you might have during your exam, or it might be something else, but that will describe you what are the numbers. And so when you do this, you have to pay attention to the elevation, which one they are. So this is north, and north is here, east is here, south, this one, and west here. So let's start with west. So the wind zone, we all know that's very high. That was in the description in the beginning of the section. So it's going to be 2. Number of story, if we look here, if it's a 1 story, it's a low risk. So we got 0. Roof to wall intersections design. So it's fully protected, partly exposed. If we look at the elevation, so it's this one here. I guess you need to look at that junction here between the top of the wall and the roof. So that's west, and so if you were to kind of turn it 90 degrees and let's say look at from this side, so that would be the west facade here. So that's this point they're asking about. And so roof intersection, so it's it's fully protected by the eave. Even though it's not that long, it's still protected. So I would put a 0, and then it eaves width. So I think if we look back into our previous drawing, I think they were writing it somewhere. So it's like 130 eaves width. Make sure that you go back to the previous drawing where they all the dimensions. So it's 130. And if you look at here, it's in here. So it's a high risk between 101 and 450. So put as high risk. And if you look at the envelope complexity, it's just like a flat face. So it's just a low risk. So it's a simple rectangular. It's going to be 0. And on that facade, there's actually no deck. So it's going to be a 0. So in total, if we start counting, we're going to have 2 here, 0, 0, 2, 0, 0, and we would have a total of 4. Now we looked at the north elevation. So it's this one here. Just going to draw over it. And so the wind zone is still the same. It's very high. Number of stories still 1, so it's going to be a low. Roof to wall intersection. So here you have to think about, okay, that edge here at the top, is it protected? From this view, it's a bit hard to see, but if you were to turn again 90 degrees, you would see that the north, this facade here, is this one right there. And if you were to see through that wall, so you would see dots, and then here you would see, like, let's say the ridge beam. So that facade here, the junctions between the wall and the roof is fully protected because we have a large eaves there. That's about, I think, at 750. So it's fully covering that junction. So so it's a low risk. There's no, well, I won't say no way, but then it'd be hard for the water to get up there. The eaves width. So because now it's higher than 600 because it's 750, and you can see that in the previous drawing. So it's a low risk again. And the envelope complexity is still a flat face. There's no like recess, or there's no recess in the wall. So it's still low complexity. And then we have a decking here, but it's a slatted deck, so it's outside. And it's not fully covered. And it's on the ground floor, so it's a low risk deck. So if you were to count total, we get 2, 0, 0, 0, 0, 0, and a total of 2. So now if we do east elevations, so it's this one. If you look at it, it's pretty similar to the west, so I think we'll have a same score. But let's just go through again. So that's this side here, rectangular. And if we were to turn 90 degrees, so it would be on that side there. So that's the point we have to focus. So like this one is the east side, and that's the west side. So wind zone is going to be 2. Number of stories still 1, so it's going to be 0 here. Roof to wall intersection, so it, because the junction is covered, so it's protected, so it's low risk. The eaves width, because it's only 130, it's going to be a high risk. It's going to be a 2. Envelope complexity, still a small rectangle, so it's going to be low. And well, there's no decking on that side, so it's going to be a 0. If we total the score, it's going to be 2 here, 0, 0, 2, 0, 0, and total of 4. And now we look at the south elevation. Wind zone is going to be very high again. And number of stories, 0. Roof to wall junctions. So here, so that's this facade there. And we need to look at that junction there. So if you turn it again 90 degrees, so you will end up on that side. So that's going to be the south side, and you can see that the junction is not covered at all. So there's like high chance of water penetrating there. So it's like fully, let's say fully exposed. Or roof with no eaves. Okay, maybe I'll just say it's partly exposed hips, gable roof with no eaves. So it's a gable roof with no eaves. So I think I'll just put 1. Eaves width, because it's like nearly 0. So it's a very high risk. 5. Envelope complexity, still super simple. So I'm gonna go with 0, and there's no decking on that side, so it's 0. So now if we total the score, it's gonna be 2, 0, 1, 5, 0, 0, and so that's gonna be a total of 8. So yeah. Yeah, so for the roof junction, I think it's gonna be medium. So it's a gable roof with no eaves, because there's no parapets, there's no enclosed balustrade. Okay, so that's question 2. Now we're gonna jump to the bracing. Okay. Yep. So the bracing, we have to remember that we're in a very high wind zone. There's 5 bracing line. So we get M here. So that's 1 bracing line. N. Then we get the A. So it's this one. B. And C. Find the bracing demand W across and W along from the table. So let's go to our table and that off as well. Okay, so our table, we need to have those values, so the H and the small h. Usually it would be labeled onto the sections. So that's the height of the building from ground to the apex, the top of the roof. It's 4.6. So we need to work somewhere around here. And the little h, the roof height above eaves, this one here, it's 1.8. So it needs to be 2. And then we go across. So those are the value, 50 across and 55 along. And you have to check what's the wind zone. So I think we hit I think it's very high wind zone. Yeah, very high wind zone, so we need to multiply those values by 1.3. So we would have the across equal 50 times 1.3, and the along, it's going to be 55 times 1.3. Calculators. So this one is going to be 65, and this one 71.5. 65, 71.5. And let's go back to our questions. This one. Just turn back on. So wind across 65, and this one was 71.5. And so now we need to calculate the wind load. So for that, we need to multiply the wind across by the length of the building. So what's the full length of the building? So it's from here to here, and that value it's 6.8. And the width is this one. That's 5.7. So if we do the calculation, it would be 65 by 6.8. 65 by 6.8. 442. 442. And the other one is going to be 71.5 by 5.7. 407.55. 407.55. Okay, so now we got question B, and now we need to label it. So the wind load across is this one, so we can just write down here, and this one here. 55. Okay. Now we feel all bracing for the building is to be provided by interior wall spanner no less than 1.2 long. So this is important. And the bracing element GS1 have a rating of 100 BUs. So actually here I think that shouldn't be EP1. I think all those ones should be labeled as GS1. So GS1, GS1, oops, GS1, 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 and 100 BUs. They're all gonna be 100. Okay, and now we're gonna start with A. I'm just gonna change color for A. Okay, so here, maybe I'm just gonna delete that because it's a bit hard to see. Because you need to know where are the windows. Okay. And let's go to the brush tool. So you can see here there's windows. So the only place where you can have bracing is where there's the walls. So it can either here, here, or here. But because they said that it needs to be at least 1.2, so the only place where you can have it is right there. So I'm just gonna delete the other ones. So we can't have it here because it's just 1 meter. This one is just 0.7. So the bracing, it's gonna be here. So A1. and it's going to be 1.2. Oops. So bracing element, so that'll be the naming. So it's going to be A1, GS1, and it's going to be 1.2. Line B. So the only place where you can have it is on that wall, and that wall is 2.8. So this one's going to be called B1. Length 2.8. And for C, you can either put it here or here. There's no dimension there, but if you look at here, if you just trace a line, it's kind of at the same size, so I would guess that those two walls there is 1.2. So you could either have it here or there. So I'm just going to put here a C1, 1.2. I mean, you could have put it here as well. It's okay. But you don't need to put both. Yeah. So now we just do the multiplication. 120, 280, 120, and so total, it's gonna be 520. Okay, and now we're gonna do it the other way. Just gonna change color. M, so it's on that line. Yeah. And we have window there, window here. We see that that wall is only 1 meter, so it's too small for the bracing. And here kind of look like the same. So the only place to have it is here. So it's 2.4, and we're gonna call this one M1. So M1, 2.4. So the BU is gonna be 240 multiplied by 100. And so it's this line here, we get window there, window here. This wall is 1 meter, this wall is 1 meter, and so the only place where you can have a bracing is here. It's 1.8. So it's going to be N1, 1.8. So you got 180, and then we just add the 240 plus 180. It's 420. 420. So we are both over the requirement, so it's okay. If you ever get lower than those loading requirements, there is a mistake somewhere. But yeah, that's it. I mean, if you have any other questions, just post it in the comment below. Thank you.